Hi guys, you are watching channel Mr. Electron, and this what you see is a 4000 watts motor speed controller that I'm going to use for DC motors. Now guys, this is going to be the part 2 video, and the link for part 1 video will be provided in the description. You can check it out. That video contains the wiring, the connections, and a few tests with induction motors, a few resistive loads and universal motors, high speed up to 14,000 rpm. Do check it out. So for this video or project, I'm going to use this plyboard, and I'm going to mount this controller on the plyboard with the help of two provided screw slots. And the next most important component is going to be a 35 amperes bridge rectifier. Without the rectifier, the controller and the plyboard look somewhat like this. Now let's make a point for drilling a hole for the rectifier. Now let's do the drilling, and I'm going to use a screw to mount it properly and strongly on the plyboard. Okay, so with that being done, let's move on to the connections of the rectifier to the controller. So guys, the two blue wires that you see are the AC terminals as indicated on the rectifier, you see. So these two blue wires will be connected to the output terminals of the controller. These two are the output terminals, line and neutral output as indicated here. So blue wires will be connected over here, and the overall output of this entire circuit is going to appear on this green wire and orange wire, and it is going to be positive and negative accordingly because the output is DC. So let's do the connections of the blue wires, and here it's complete now. It looks somewhat like this, and guys, this is a 24 volts DC motor. So I'm going to use this motor for testing this controller. It is just 24 volts, and I'm going to run it from 60 to around 220 volts max. Like, I'm going to force it. Okay, so because it is free load, like it is running freely, no load has been given to the motor, so it is not going to consume much of the current and run easily without burning out. So let's start it. This is a pretty big DC motor with a big flywheel attached, and it is 180 volts, 4000 rpm, and an input current of up to 4 amperes. So I'm going to run this with the controller. So guys, that's all for today's video. Thank you so much for watching it. Links will be provided in the description, and don't forget to subscribe. See you in the next video. Guess what guys, I'm going to use for this project is an inline carbon filter. Lying around, dead one, scrap. Well guys, it seems like that I'm going to use this DC motor. Super. So guys, here as you can see that the surface cut is a little uneven, you see. Now guys, for precision cutting I have this super amazing milling machine, okay. So yeah, let's first clean it up. Alright, let's do it. So guys, you can see that it is pretty stuck good. Yeah, now it's time to install it finally. There are 4 wires, which means that this is a DC clutch motor. This is the clutch, and the 2 thin wires are responsible for operating the clutch, and the remaining 2 thicker wires are for operating the DC motor. I have used some cushioning to reduce the vibration, as well as I have added screws of equal length to further minimize the vibration, plus the zip ties to hold this like impeller piece steady. Well guys, here as you can see that it is super cloudy and the sun is barely available, but still I am going to use the solar panel wires that I have here. You can see that when I run it, it has started running, but there is no movement over here because of the DC clutch action. Seems like it's working fine. Whoa! Super guys! Little water is left. See guys, superb water pump. So guys, this what you see is a 24 volts 3 amperes permanent magnet DC motor. So I'm going to use this motor to test its torque value with the setup that I made. This is the drill chuck with 0 to 10 shaft connectivity, and I have welded the metal piece to the drill chuck. So this drill chuck can adapt shafts from 0 to 10 so I can also test the motor torques with shaft sizes of 0 to 10 of course. Okay, now I had to change the motor because it did not have a base stand, so it was difficult to fit it to the vise. So if you need to fit a bigger thicker motor to a vise, you will need a bigger one. Okay, so this motor is in its place. I'm going to use this iron cable to connect it to the weighing scale, digital weighing scale, and the drill chuck. And the groove of the drill chuck is going to keep the wire steady and pretty tight. Okay, now when I'm going to power it up with this 24 volts 3 amperes power supply, the motor is going to start running, and it is going to pull the weigh scale, and the weigh scale is going to display the kg weight it is picking up. So guys, as you saw that the maximum displayed weight was 14.86 kgs. So the torque value is going to be 14.86 kg centimeter because the shaft welded to the drill chuck is 1 centimeter in radius. So guys, this is another motor, a little smaller one. Let's measure its torque. It showed somewhere around 12.64. So the torque value is also going to be 12.64. So I didn't have a waste TV, so I used a dead monitor from an old type of CRT computer. guys, the question for today is which scientist worked mostly on high voltages? Again, which scientist worked mostly on high voltages?